The next function that we are going to discuss is the creation of a list that will contain the elements reversed of the original list. So we can say is basically how we can do reversing a list. Okay, the steps basically are similar to the copy list that we have seen previously. In this one, what we have to do is just connecting the nodes in a reverse order. Let's take a look to this example. Okay, let's consider this list given here with Dhaka containing value 10, Khulna with value 20, Sylhet with 30 and Comilla with 40. And what we want to do is create another list but containing exactly the reverse element. That is, it will have the 40 with Borishal, 30 in Chittagong, 20 in Rangpur, and 10 in Mymensingh. So basically we have a simple list containing the elements in reverse order. Here, as you can notice, the addresses are different, so is not the same list. So is a different list and different objects created, so it will be similar to the copy list. There is another way of doing reversing, which is basically without changing the addresses of the objects, we can just change the link, but that will require a little bit of processing. We will see how to do it in the next function. For now, we are going to see how this can be done by copying the elements in another list. So basically, as it is going to reverse the list using new created objects, this reverse function is known as a outplace reversing. Outplace means basically it not using the already created objects. Rather than that, it is creating new objects in order to build the new list. So this is known as outplace. We'll see the in place in our next function. Okay, let's see how to do this. So basically we are going to use copy head as a variable. Okay, we don't need copy tail here like in the copy list, because we can change the head while we are creating the nodes, because the head will be pointing out towards the last element, so it doesn't matter if we change it. In the previous case, the head cannot be changed because the head should be the first element, but here if we look at the elements, the last element is the first one that we're going to appear in our new list, so we can change the copy head reference. That's why we don't need any copy tail here. Then we have the iteration of the list. It is going through the first list. We're starting from Dhaka, will go to the Khulna and so on. We are going to create objects from the list, and how we are doing this? By using our node constructor. We are passing the elements that are contained in the node objects of the first list. So initially new node will be the value of the object that is first in the given list, which is 10, and the pointer to its next reference is null. The next step will be the similar to the copy list, is basically checking if my copy head is null or not. Okay, if the copy head is null, then we assign the new node as a copy head. Otherwise, what we are going to do? What we have to do is just connect the new node.next to the copy head and modifying the copy head reference to the new head. So in the previous case, what we were doing, it was copy head dot next new node, but here we are connecting the link in reverse order. So basically we are already generating in reverse way. So we'll have 10 pointing to null in the first case. Whenever we have 20, 20 will point towards 10. and not 10 pointing towards 20. So this is how we are reversing the link. And the last statement is returning the copy head. If the first copy head equal null happens, that is basically the creation of the linked list. Okay, so the next function is reversing the list but doing it in place. That means we cannot create new nodes. We have to revert the link within the list. So for that we are going to need basically three references. One will be the reference to the new node, which is basically showing it here, new head, initially pointing to null. Then we are going to have an iterator that will go through the list, which is basically n. And the next one will be the pointer, where I'm going to save the rest of the list whenever I change a link. Okay, so let's see the simulation first, then I will show you how to do it in code. Okay, so let's consider this list. So initially I have the list given where I have 4 elements, 10, 20, 30 and 40. I have a pointer which is the new head, and then I have another reference which is pointing the starting of the list, which is n. Okay, this n will be iterating through the list whenever I go through connecting the links. Okay, so initially new head is null and n pointing to 10. As I already mentioned, I will need another pointer which is known as next node. That is, the first link that I'm going to change will be the link between 10 and 20. So if I change this link, 20 will be lost if I don't save it. So I need to save this link by using a next node reference. Okay, so here is the next node reference. Let's see how we can do it. Okay, so the first case will be changing these links. Next node is already saving 20, so I am not going to lose the list anyway. So I can change the link. So let's change the link. 10 will point to whatever is pointing by new head. Okay, so 10 is pointing null right now. Now what I have to change is the pointer of the new head, because new head initially was empty, but now the new head can have the first ever node created here, which is 10. Okay, so 10 is pointing to null and new head is pointing to 10. We already have now our first element of the list, so we can advance the iterator of n. N should be pointing now whatever next node is pointing here. Okay, so n is goes to the next node reference, and now I'm gonna change my next node because I have to change the link of 20 and 30. So next node becomes 30. Now it's fine to change the link between 20 and 30. So 20 and 30, it should be changed, and 20 should point towards 10. How do I know where's 10? 10 is saved where? In the new head reference. So I can just do n.next equals to new head. That's it. Very simple, right? So after that, now 20 should be my head because I am creating a reverse list, so I have to update the pointer of the new head. Okay, so new head is pointing to n. Similar process we are going through for changing the link between 30 and 40. N should be pointed here in 30, next node will be 40. I will change the link between 30 and 20. Then I will change the new head as 30. N should be pointing to 40 now. Next node will be pointing to null because 40 has null in the last reference. Then I will change n.next equals to new head, and new head will be updated. That's all. N will be updated to null. That's it. The list has done. We have the complete reverse list here. So let's take a look to the code now. Okay, here is the code. We have used these 3 pointers. I have a simple loop which is the while, where I'm controlling the iterator n. So initially new head is pointing to null, then I have n pointing to head. My loop goes through I found n equals to null. So I initially assign next node as a n dot next, which is basically if my n is 10, this will be 20. Then I change n dot next equals to new head. Then I change the reference of the new head to n and change the n with the saved address by next node. That's how we go through the loop. And then the last statement is returning the new head reference, which is basically 40 in the sample given. So that's how we can do the reverse lists in place. We just have to have an extra variable where we save the address of the link that I'm going to change. Okay, so that's how this is looking. The new head will be pointing to Kumilla. The last operation that I'm going to show you is rotation. We can rotate a list to left or to right. In this lecture, I'm going to show you how to do left rotation and give you a hint for right rotation so that you can solve it by yourself. We'll see the code using an example. So let's take a look to this example. I have this following list with 4 elements, 10, 20, 30 and 40, and its corresponding addresses Dhaka, Khulna, Sylhet and Kumilla. If I rotate this list one time, rotation to the left, the list will looks like something like 20, 30, 40, and the last element will be 10. So the element which is appeared as the head element will go to the last position and will connect with the last element. Okay, so let's see how we can do this. First of all, I'm going to use a variable named as all head to save the value of the head before removing the connection. Okay, so here I have saved it in the all head is pointing to Dhaka right now. Now I'm going to change my head pointer. So head will point to head.next because my list will start from 20 right now. Okay, so head is moved to 20. After that I will need a tail reference which will go through the list and find out the last valid element. So here I assign a tail as my head, so tail will appear here. Okay, and I will go through the list finding out the last valid element using tail. So now I have the last element. I'm going to connect this last element to my old head because 40 need to be connected to 10. So tail.next is equals to old head. Now the link is connected and the next step will be removing this link that is connected with 10. This one. So how we can do this? Just doing all head.next equals to null. That's it. And now we have to return the head reference of this list. Return head. This is how we rotate a list left. If the rotation is done one times, if we have to do it k times, we have to call this function k times. That's all. And for rotating the list right, what we have to do instead of doing in that way, we have to find out the tail node, which is in that case should be 40, and 40 will be the head of the list. So we find out 40, we connected the head and delete this link that connects 30 to 40. That's it. So that's all about advanced manipulation and linked list. Thank you.